Begins. Okay. So, what is a colligative property in the most basic definition? Somebody from the back area over here, Julian's area back here. What is a colligative property? Okay, let me add to that change first. So she said it's just a physical property of a solution. So everybody in here knows that a property is just talking about the characteristics of a substance, right? Well, water, for example, has a very, very specific boiling point. What is water's specific boiling point? 100, right? So water is the solvent, and the solvent has a specific boiling point at 100 degrees Celsius. What's its freezing point? 0 degrees Celsius. So what's happening is whenever I add a solute to a solvent, the properties change. And so you kind of already knew that because you know that when we put salt in the roads don't freeze. When we put salt in our water pasta that we're trying to make for dinner, it doesn't boil over. And so there's something that's interacting that's causing the property to change. Quick question, Justin? So that's basically what a colligative property is. It's a procedure. It's a property that's based on us adding a solute to a solvent. So many times our solvent will be water. What were some of the other solvents you saw in your problem sets? Yeah.
Acetic acid, or no, that's from lecture.
Go ahead.
That's on the lecture.
What was it? Acid?
Acetic acid.
Acetic acid. Gotcha. Acetic acid. You're good. Acetic acid. I'm glad you said that because we're going to talk about acid nomenclature Friday. Another one? Benzene, C6H6. You guys remember this one from the guy that died? The killing of Casey, the guy on the floor back there?
Oh.
Benzene, C6H6. That's the molecular formula from the empirical formula, which is CH. Right. Okay, so that's just a quick review. Okay, so there's other solvents out there. Each of the solvents have a very particular constant that's related to them. It's called the Malau freezing point constant or Malau boiling point constant. How is that written or how is that expressed in your notes? What's the Malau freezing point constant? Okay, 1.8. So you're saying K, right? KFP. So if I said Malau freezing point constant, you're thinking K. Well, KFP for water was particularly 1.86 units. Celsius per Malau, right? And so this is very particular to water as a solvent. And I put that K table up on your Google Docs so you can see that different solvents have different K values just because they're different solvents, right? So as you're going through an equation or a question that's like, oh, how much does the freezing point of blank solvent decrease? You should be thinking of delta T is equal to Chem. So Chem won't forget this equation, right? So I replaced a teacher and her name was Chem, and so we used this equation, and they were like, I'll never forget this. Okay, so the temperature change, if it's going to be freezing point depression, it's going to be going down. If it's boiling point elevation, what's going to happen to the temperature? It's going to go up. So you have to kind of think in the mindset of which type of question am I doing, and then you have to realize that the K is in reference to the solvent, and so water many times is our solvent, so you're going to look at the table of the K's for the solvent. What is the I referencing? Yeah. Okay, so the number of particles that the solute either dissociates into, if it's able to dissociate, or the number of particles that just inherently takes on. And there are two types of compounds that we generally deal with, ionic and covalent. Ionic compounds will break into ions. They will dissociate. So one of the examples is at the very bottom of your unit review. Give me one of those on there on the unit review that you are struggling with right now on the I factor. Shout it out. So last question on the unit review. Yeah, the number of NH3. Okay, so one of the examples that Rishi said is NH3. So your job is to tell me, first off, is that ionic or covalent? Everybody. Why is it covalent? It is non-metal, non-metal. It is covalent. Do covalent things dissociate in water? Can you pull apart a oil particle or a fat particle or, I'm trying to think what else. Ammonia. No, you can't. So this I factor, because it doesn't break apart anymore, is just one thing in itself. That I factor is 1. So I will use 1 in my KIM formula. Question?
No, I have another one.
Yeah, go for it.
Along with the last one.
I'm ready.
CH3.
CH3.
OCH.
OCH2.
CH3.
Okay. Identify. Is that ionic or covalent? Everybody. Why is it covalent?
All non-metals.
Carbon, hydrogen, oxygen. Carbon, hydrogen, carbon, hydrogen. Okay, all nonmetals it is. I don't see a metal in sight, nor do I see any polyatomic ions, right? So this is covalent. So the I is 1 again. Okay? So let's do like aluminum bromide. What's the formula for aluminum bromide? Aluminum. Okay, great job. Can I get bromide? Br, but how do they chart? Look at aluminum's charge. Does everybody see aluminum's charge is a 3+? It's in the third group. And then Pr is in the 7th group. It gets a -1 charge to get octet. So we're kind of throwing some review as we can. Crisscross those, you get Al, Br3. So this one in particular, I want to actually write out as a dissociation because it is ionic, so it will dissociate. So that's going to be AlBr3 dissociates, this is a solid, dissociates into its different ions. What's one of the ions that it takes on? It's the ions that made it up, so it's not a question, so it's up here. Aluminum, what? 3+. Ions have charges. If you put aluminum, I'm going to count it wrong because it's not an ion. Ions have charges. So there's 1 aluminum because there's 1 subscript here. How many bromines? There's actually 3 here, right? This 3, I know you're saying that's coming from aluminum's charge, but that means that I need 3 bromines to counteract the 3+ charge of aluminum, so I need that. So when I break it up, I do break into 3 Br charge of bromine, 1-. So this is called a dissociation equation or ionization equation. So when you have to write it in your review and your problem set, you're doing something like this. These are aqueous. Okay, so how many ions does this break into? 4 total. 1 + 3 is 4. So the I factor here is 4.
That's dissociation.
Yes.
Okay.
Great. Okay. So in terms of what is I does depend on the solute. So knowing that the K value depends on the solvent, the I factor depends on the solute. What is the M value reference? Kind of both, but how is it representing both, Jillian? Go for it. It's the molality. It's little m, but what is molality again? Moles of solute over kilograms of solvent or solution. Solvent, right. So little m is equal to moles of solute over kilograms of solvent. So it does kind of take on both. By recognizing which one's the solute and solvent, sometimes it's half the battle. Okay, so does that kind of recap yesterday a little bit for you? Yeah? Let's do a question related to that. So I just copied the questions from the problem set. I'm going to scooch down to one like this first. So the Van 't Hoff factor, which is what I's term is, because everybody's going to have their name on something. Can you guess who discovered I? Mr. Van 't Hoff, right? So his constants are going to be related to number of ions that they take on. So go ahead and do this one, guys. Let's do, what's the name of that? CaPO4, blah, 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 blah. All that together. What's the name? Calcium phosphate. All right, so go ahead and dissociate that for me first. And if you guys could participate, we'll kind of move on here soon. So this dissociation is good. So it's not truly like, it's not a formula, right? It's not an equation. It's like the balance chemical equation on how we're breaking this ionic compound up. So I see 2 things here. I see calcium and I see phosphate. Those are going to break up. So I know that calcium and phosphate, PO4, what's the charge of phosphate? What's the charge of phosphate one more time? 3. Don't forget this 3 right here came from phosphate, right, from crisscrossing. What's the charge of calcium? 2+. Okay? So those are the 2 ions that make up calcium phosphate, but how many of each of them are present within my compound as a whole? How many calciums are here? 3 of them, because there's a 3 right there. How many phosphates are here as a whole? 2 of them. So how many ions have I made? Say again? 5. 3 plus 2 is 5. So whenever you're writing your dissociation equations out, you will have to think about, is it an ionic compound? Yes. What are the two ions it makes up? Break them up. And then label them with their charges and how many of each of them you have, and then you can add from there. Okay, so going down to question?
Oh, I was just gonna ask, go over the second.
B?
Yeah.
So nickel, what's the name of this, by the way?
Oh,
Nickel what? Nickel 2 phosphide. Good, because the 2 comes from nickel's charge, and that P is phosphorus, but we had to change the ending to I. So nickel 2 phosphide breaks into nickel and phosphorus. But what are the charges of both of those? What's the charge of nickel? 2 plus. What's the charge of phosphorus? Phosphide? 3 minus, because it's in group 3. Nope, group 5. Sorry, group 5. How many of the nickels do we have? 3 of them. Thanks, CJ. How many phosphoruses? 2. How many ions total? 5. 3 plus 2 is 5. Good job, guys. Okay, so I'm going to scooch down. I'll come back to a couple of these in a second. This is my numbers got mislabeled when I copied them on here. This is number what? 11? 8? This is number, no one asked for 10, my bad. This is number 11. Here we go. 11? Okay, so calculate the change in boiling point. Okay, so boiling point, is boiling point elevated or depressed? Elevated, so we know that's going to be an addition of the delta T, so that kind of gives you a quick reminder. For the following solutions, determine the new boiling point. So this is the new boiling point, that's our question. 1.5 millau calcium chloride in water. So let's do this one first. 1.5 millau. What's calcium chloride's formula? CaCl2. Good job, Chloe. In water. Water's our solvent, right? So if water's our solvent, what quantity or what characteristic is important about the water of our delta T is equal to KIM? This is our colligative property temperature change formula. Which of these variables do we need from water? The K value, right? So we're looking for K BP at this point, right? On your stuff from yesterday, what's your K BP for water? 0.5 what? Benzenes and water is really close. I always get them mixed up in my head. Okay, so KBP for water is that. The molality for the solution as a whole is 1.5 millau. What else do I need to know? I need one more thing, guys. Look, I got K, I got M. What's the ions formed from calcium chloride? How do you get 3? Ca2 plus, gotcha. And Cl charge 1 minus, but how many of them? 2 of them. So I'm going to say 1 for calcium plus 2 for the chlorines. I equals 3. Hey, I equals 3. So at this point, I can plug it into delta T is equal to KIM. I have M, I, and K. So K is 0.52 degrees C per millau. I is unitless, which is awesome, right? We just put the number of 3 there to say that there are 3 ions formed. M is 1.50 millau. What units cancel? Millau, so millau and millau. So degrees Celsius is good because our temperature should be in a degree Celsius. So what is this, by the way? 2.34 degrees C. All right, is that my final answer? No, the question said what's the new boiling point? Well, what was the solvent originally? What was the solvent's boiling point originally? Sorry. 100. So water's boiling point is 100 originally, but now we're elevating it, so we're adding our delta T to this. So we're adding 2.34. So what's our final temperature? 102.34 degrees Celsius. Okay. Does that help with the second part of 11, or should I do that one as well? That one's probably the harder one. Yeah, Nick?
Do the ions have a unit? Just as
It's unitless. No, it's unitless. Just the number. Okay, so I'm going to do B as well. If you don't need me, keep doing whatever else I asked you to do to make your study guide and so forth. Okay, so delta T is equal to KIM. We're still working with the same formula, but now let's talk about the new solutes and solvents. Who is my solvent? Benzene. C6H6 is my solvent. What do I need to know about my solvent? It's K value. So what's the K? And this is still boiling point because it's still from the same question. Looking at your chart from yesterday, I gave you on your notes. What's the KVP for benzene? 2 point what? 53 degrees Celsius per mole. These are not things you should memorize. I'll always get them to in your equations. What's the I factor relevant? Which of these is relevant for the I factor? Carbon tetrachloride. What's that formula? CCl4. Good. Ionic or covalent? Say again? It is covalent. So what is the I factor automatically? 1, because covalents don't dissociate. They don't have a dissociation equation either. So the I factor is 1. KBP is that. Now we're looking for molal. I don't have it given to me straight off the bat, so I need to calculate it myself, which you guys have the power to do. What's up? Bring it up here. So I told you guys yesterday, dilution equation, or the other day, Friday, dilution equations used like daily. This is what Justin's doing. You guys have your molality. So how are you guys starting off up on your molality? You need moles of solute over kilograms of solvent. How do I get to moles of solute? Anybody? Take the molar mass of who? Carbon tetrachloride. So I need that molar mass for you guys. So 40 grams of carbon tetrachloride. Go to moles. 1 mole of carbon tetrachloride weighs. Thank you. 8.3.
8.2.
That sounds good. I got like 153 in my head, so that works. Can you go ahead and take 40 divided by 153?
0.26.
0.26 moles of the solute. Okay. So we have the numerator for our molality. Now we need to get our denominator. Well, that's almost perfect as is. We have 450 grams. How many kilograms is that? 0.45, right? We're bouncing decimal back 1, 2, 3 places. So that's 0.450 kilograms. And so at this point, I can get molality by doing 0.26 moles of solute divided by my 0.450 kilograms of benzene. Doesn't necessarily matter if you label it. I'm just recognizing my solvent and solute over and over again. So what's this 0.62 divided by 0.45? Okay, that's good. Okay. So I have M. I have I have K. What do? Multiply them all. What do I get? Delta T. What's delta T? Say again. 1.46 degrees C. You need to show your multiplication. I'm just processing this right here on the board for you. And so this is our delta T. This is our change in elevation of boiling point. Now the point is, like, what's the normal boiling point of benzene? You don't have to know these things off the bat, right? You can Google this. Did anybody Google the normal boiling point of benzene? Jacob.
170.1 degrees Fahrenheit.
Say it one more time.
170 degrees, 170.1 degrees.
Oh, degrees Fahrenheit? We don't say the F word in here. I need something else. Celsius. Yes.
80.19.
That sounds better. Okay. 80 point what?
19.
Okay, and that's for benzene. So that's the normal. I don't know how to convert Celsius and Fahrenheit in my head very well, so I can't do that. Okay, so then I need to add my delta T here. So what do I get? I hope the right answer. 81 point. Say again? 0.65 degrees Celsius, which you can round to 81.7. Right. All right, so colligative properties by far was the newest thing for you guys, and I think that you have a better grasp of that than you think you did. So I'm going to transition to continue your review without me. I'm going to do a couple more prompts on the board based on the questions that were asked here. Also begin making a personalized study guide, like I said, with gases, thermo, and solutions. And then I'm going to leave that to you. I have a couple more papers to pass out as well. I'll keep you in questions for more and less. Everybody's happy. And if you guys need to get up and move, I have lots and lots and lots and lots of papers to pass out. I'm going to do one. I just wanted to not do it as a whole class. I'm just going to do one. Okay. Ready? So Chloe, this right here is the solubility of potassium chloride in 100 grams of water. Okay, so that's just like the ratio. I have 0.456 moles in 100 grams of water. So if I have 500 grams of water, I should have 5 times the amount, correct? That's just a ratio perspective. So I'm going to actually show my work for that though. So I'm going to say, okay, if I have 500 grams of water, and my particular concentration is 0.456 moles of KCl in 100 grams of water. The grams of water cancel each other out, right? And so that's good. Now I'm to moles of potassium chloride. The question says mass, so I need to do one more step, which would be what? Molar mass, right? So potassium weighs like 40, 30, and then chlorine weighs 35.45, so it's like 75.45. And 1 mole. And so solubility curve. Or basically you can use a solubility curve, but I gave you the point that's on the solubility curve in moles versus in grams, so you could have converted it from there. What was the other one? 6? Okay, I'll get down there in a second. Okay. Number 1 for the problem sets on the board as well. I gave you some guidance. Let me know if you don't understand what this is. Basically, the moles per gram were given to you, but you need to get to grams versus 500 milliliters. Guys, I'm giving you an opportunity to work in groups. Please don't make me reconsider that, okay? So I want to see progress, progress, progress.
Okay, cool. Thank you. You want me to transfer to one of the containers that you have for point two, or leave it how it is?
Where's it at? I'll transfer it out. After I use all that's in that little tiny one, I don't want to mix an old solution and new solution, so I'll pour it in there after that.
Yeah, I didn't know if you wanted to. There's an old container that was used for point two, but it's empty.
Clean?
It's empty.
Is it clean though?
I don't think so.
Okay.
It's just in the back.
Well, then clean it out and we can put it in there, then that works.
Okay.
That's good for me.
Do I need to clean the silver nitrate containers in a certain way, or?
Don't get on your hands because you'll turn your hands black.
Don't want that.
Other than that, you're fine.
Okay, you could before like a rest. I'm not too many things like. Yeah, and like as I walk out, like it starts changing color.
Yeah. Yeah, do what you do.
Just water, just like blast it with water, and
yeah, no soap in the volumetric ever.
No, not in the volumetric. In the
brown container.
Yeah.
A lot of water. I won't put any soap in it.
No soap?
It'll precipitate the solution.
Alright.
Just soap's good at precipitating things out. So.
Alright.
Alright. I'm doing number 6 on the board as well, if it helps. Number from the problem set.
Yeah. As the temperature of the liquid heat line, so the solubility of the gas in the carbonate causing taste black.
The water.
So if you need to listen to number 6, I'm briefly going to explain what this means. So just halt your conversations. Continue if you don't need me, but just be quiet. The number 6 said equal number of moles of calcium chloride and sodium nitrate. Well, those are different numbers of ions. I of calcium chloride is 3. I of sodium nitrate is 2. Well, the key word here wasn't really anything outside of the word lower. So if you're talking about freezing point depression, we want it to go really low. We want that delta T to be huge. How do you get a very large delta T? Well, mainly the thing that's controlling the delta T is this I factor, the Van 't Hoff factor. If you have a lot of ions, it really significantly depresses the temperature. If you don't have a lot of ions, you don't depress the temperature. So be quiet, just don't shout out for me. So this is our calcium chloride versus sodium nitrate, which only has a 2. That's going to be caused by the number of ions more specifically. The question about lower boiling point, you have to kind of think back to how is boiling point changed when I make a solution. Boiling point's changed by elevating it. So if I want to make a really big impact in my boiling point, I'm going to add a lot of things that make lots of ions. That's going to really, really, really elevate my boiling point, raise it a lot. But the question is not about raising the highest boiling point, it's about getting the lowest boiling point. So what would not make it increase quite as much? It's going to be something with not as many ions. So 2 ions versus 3 ions is not going to elevate the temperature, boiling point temperature quite as much. And then since vapor pressure travels in the same direction as boiling point does, it's vapor pressure lowering. Light, same as freezing point. It's the same as the freezing point answer because it's going in the same direction. This is freezing point depression and vapor pressure lowering, so they travel in the same direction. So that's why they have a very similar answer as well. So keep working. I'm going to come around to you guys for more questions.
Okay, it's the dilute equation.
Wait, what was your answer?
7.5.
I solved it with all this.
We would add as one
I have a couple people passing papers out, so just make sure you're aware that you have papers flying.
So we can add is it Oh, so we should add 5.9. Oh,
I never.
5. We do, what is it, by the math? We got 1.36. It's for the first one, I think you math by we take the math values over the math. Oh, wait, no. Oh, right. Oh, right. We need to step out of here.
Almost everything else on this. Tell me what it is. Colligative.
What did you get for it? Like, it's 25%. Yeah, that's what I got too.
I was just going to
I got oh yeah. Yeah. No, I get
Huh?
Alright, you guys can go back to your work in a minute. I want you to come back towards your desk and pull up your phones for Kahoot on Thermo. I'm taking questions right now, but pull up your phones for Kahoot. So come back to me. Come back to the lights. You go sit in the back, please. Because I need that for you. You might need a calculator, FYI. We are starting in 30 seconds.
Once you get on the last
Alright, and I need to see more people on here after I started. Aha! I thought I clicked that. If you want to pull up on your computer, that's fine. If you want to pull up on your phone, that's fine. Game pin 3, 4, 6, 2, 1, 5. 3, 4, 6, 2, 1, 5. So, I am taking this for a grade along with your, I'm lumping it with another quiz grade that you're going to have later. So, make sure you pay attention. You should have a reference sheet in front of you just in case you need one. The reference sheets have thermochemistry equations on the back lower left corner. Have something just that maybe if you can share in front of you, that's fine. And you know what? We'll make this partner. Sit together, calculate together, answer on your own phones though, so I can have your name down as well. You may sit with a partner if you'd like to talk about this. That was my alarm to get started. You ready? That's okay, the answer is no, but I'm going to start in about a minute. Let's turn my alarm off. Alright, guys in the back, Robbie and EJ, can you guys see? Okay. Alright, and the games begin! Yay! It looks like it says a pirate's favorite jewel. The game comes right here. Exothermic or endothermic? I'll turn the sound on in a second. Exothermic or endothermic? Okay, most of us do remember endothermic ends up high. Very good, very good. Does temperature measure potential energy or kinetic energy? This will take you about 30 seconds or less. I have the power to skip you as well. Be ready. Nice, guys. Very good. Salt. Oh, no. Here you go. I said get close. Calculate the initial temperature of a cup of coffee that was cooled down to 20 degrees Celsius if the overall temperature change was negative 34. This is a good 10 more second question. my. First off, pause. It said cool down. So if you try something lower, it says cool down. So you're going from a high temperature to a low temperature. But it went down by 34 degrees, so you had to start off 34 degrees higher than where you were. So 54 it is. Nice. Solve. Don't whine.
Don't whine. Calculate the heat given off when 122.9 grams of copper cools from 178 degrees Celsius to 74 degrees Celsius. The specific heat capacity of copper is 0.385. Mostly good. It did say, I don't have the question in front of me. You had to find a Q from MCAT, and it says released, right? So that's why it was negative. We're good there. All right, next. Solve. I got two more like this. You guys are whining. Stop it. You needed. Wonderful. Most of you guys are doing fantastic. Next one. What is the melting point for a substance in the phase diagram? Had 3 people choose blue. Okay, give me this thing in the air. This is the very beginning of the phase diagram. What is, the heat curve. What is this? Solid, and then it melts, and then it is liquid, and then it vaporizes, and then it's gas. So you should know that. We've looked at these about a month now. Which regions of the diagram show only the potential energy increasing, not the kinetic energy? Not the kinetic energy. let me give you that as a recap. Temperature and kinetic energy are directly related. So when temperature is changing, that means kinetic energy is also changing. You can't choose the slants. You have to choose the flats. The flats were B and D. Nice, 17 of you. 6 of you, get on our level. Yeah. Solve. Ooh, this is little. That's why I said closer. Determine. Squat. I'll read it to you. Determine the number of kilocalories of heat produced from the reaction of 15 grams of calcium oxide with excess water. It gives you a reaction, calcium oxide plus water. You might want to balance this. Yields calcium hydroxide in 15.6 kilocalories. I couldn't make this any bigger. Sit down right here. Sit down right here. Sit on the way. I don't know what this means. You have 86 seconds. You good? Keep writing on my arts and crafts.
I don't know what this means. What does this mean? I don't understand. I don't know what I'm trying to find though.
You guys have more power to your grades than just a quiz.
Yeah, I don't know what this means. What am I looking for? What am I trying to find? I don't get it. I don't know.
You got the lights back on. You got the lights on. All right, let me recap this for you because I got 4 people who understood. So here's nice, Margaret. Okay, so I'm gonna have to write on the board for me. So give me 1 second. All right, so. Oh no. All right, and back with me for about, I need a minute of your time left, and I have one more thing to tell you for tomorrow, and then you guys can finish working. That question had calcium oxide. Write this down for yourself. You can not include this in your study evidence for tomorrow if you'd like, because this is a question that's just like some of the ones we did with our thermochemistry. Calcium oxide plus water yielded calcium hydroxide. Is this balanced, yay or nay? Yes, it is balanced, so 1 to 1 to 1. So I tried to leave it as easy as I could there. I should see you writing this down. I had 4 people get it right. So everyone should be writing this down with us as we go, especially if we complain that we don't know what's going on. This is your helpful piece of information. So it also gave us the 15.6 kilocalories. It's just like kilojoules. It's just a form of energy. It's just to give you another look at what energy could be expressed as. And since it was on the product side, that meant it was exothermic. So that's just quicker for you with the thermochemical equations. You have that on your foldable as well, though. It said I think it was like 15.6. 15.0, thank you. I'm trying to remember the question. 15.0 grams of calcium oxide was put in water. It said how much energy was produced. Well, don't forget, guys, this right here is basically like a mole ratio. This energy is directly related to 1 mole of calcium oxide because of the mole ratio that's existing within that balanced chemical equation. So the very first step you have to do is probably convert grams to moles, right? Probably to moles. So that's going to give us, I think, calcium, so let's see, 40 plus, so it's 56-ish grams of calcium oxide for every 1 mole of calcium oxide. So you could convert to moles and call that a day, but then you wouldn't have achieved the information about energy. Well, the relationship here is 15.6 kilocalories is equivalent to 1 mole of calcium oxide. Where would I put 1 mole here? Bottom, right, thank you. So 1 mole of calcium oxide produces 15.6 kilocalories. So I can estimate this in my head. You would not, I don't think you really need a calculator here. So 15 divided by 56, that's about 1/4 of it, right? 15 goes into 64 times, so it's about 0.25. So 0.25 times 15.6, so what's 1/4 of 16?
4. It should have been the one that was approximately 4 kilocalories. You could probably estimate some of that in your head. So 15 divided by 56 is about a quarter, so 0.25 times 15. Well, it's a quarter of 15. Oh no, but a quarter of 16 is 4. So that was like the blue one, 4.16 or something like that. Yes.
Where'd you get 0.25 from?
I did 15 divided by 56. I approximated there. That's not exact. Okay, so that's a thermochemical equation that I would expect that you'd be okay with. All right, so to wrap, we got about 10 minutes left. If you need to look at science in a box stuff, look at that now. Work with whoever you need to on that. Tomorrow, you guys are doing 2 labs. Ready? I'm sorry. Pause your conversation. Pause. Tomorrow, you're doing 2 labs. You need pequeño jars, okay? Not really large jars. And if I think your jar is going to use a lot of the materials because I have to have some for first and fourth, then please, make sure that you have something. You guys might have to work together if that's going to be, if the jars are too large. Second, we're making ice cream. Colligative property lab. Okay, we're going to do some calculations for that as well. So if you have toppings that you're like, I need this on my ice cream for breakfast, then bring those in because they know it's going to be a breakfast ice cream because it's at 8:30 in the morning. So just make sure that you guys bring in some things. I'll bring the milk and all the things to make it. If you want whipped cream and cherries and strawberries and bananas and sprinkles and chocolates and stuff, you got to bring that by yourself. Okay. So science in a box groups. Work on that. Work on your review. If you want to, absolutely. Yeah, absolutely. Chloe, I forgot you guys. You can use what do you need? My phone? The bowls are in the back left. They had to go upstairs real fast. They're going back.
I can put in the section background of these cars.
I want to see
Oh, you guys are
You listen to me? You can listen to right?
I was 4 of 7 and I kicked out the last question.
If I call your name, please continue immediately. I'm giving you guys your assignment of post reading. Maddie.
Raj, and Leo. Mariana, Marcy, Kyle, Miles, Cameron, Julian, Taylor, if you do not get an article, please come see me right now.
Oh, it is?
Thanks, guys. Sorry. So Jacob, same as last one, some comments. Okay.
Can we make this a paper?
Put it on there. Yeah, always that way. That's why I printed it for you.
She hasn't really like done much with our scientific project, so like, how should we
Or video have done like your videos. I'll have her do some additional later videos. But I do tell her to submit that here without her, and she can't go without people. I mean, so you're good. All right, guys, your laptop should be going up here in about 2 minutes. Okay? I don't know what that was. Copy. So if you guys would like to write this down on your documents that you just got, this might be important for you to have. I added one thing to our normal close reading. Your close reading for tomorrow will be 10 comments or annotations, which is just highlighting and annotating in written form or making a comment about the paragraph as a whole. 25-word summary, which is normal, and do include some chemistry. There's a lot of chemistry, some really cool parts. 2 sentences of reflection. Some people wrote like very good comments for reflection last time. Say 2 sentences or more if you like. And then additionally, give me either, maybe you have an image in your article that's really great that you can show someone. And that you can show someone for your share, or you can even draw a picture or an image that will describe the chemistry behind it. Just to give them a visual of okay? And is anybody going to be someone I'm looking for science robots? Final document sent to me by Friday. Embedded in your document is a YouTube video. And then laptop certified.
Wait, so if we really do